Good morning, dear students. Welcome to the e-learning class. So in our previous classes, we already studied about the surface area and volume of some combination of solids. Okay, it may be, I think you already studied about the combination of cylinder plus cone, then hemisphere plus cylinder, then hemisphere plus cone. Okay, so we already studied about these combination of solids. We already found their surface areas and volume also. We know how to find the surface area and the volume of these combination. Okay, so today we will learn more and some complex combination of these solids. Okay class, so let's start the class. Okay, now this boy has three type of colors. So first he made a hemisphere from blue, and then after some modification he finally made a cone. So as you can see, this solid is called, yes, good, it is called cone. Okay, now what if we cut some portion of this cone from the upper side? Okay, and this is again, so he made a sphere from the green, and now he made a cylinder from yellow. So now he has three types of solids. Okay, first is, yes, cone, second, tell me, sphere, and third one is, good, it is cylinder. Now blue one is cone, and then yellow is cylinder, and green is sphere. Now again he changes the shape of cone into a sphere. Okay, now I think you observe this very carefully, that when he changed the shape of cone to a sphere, but did he change the quantity of that object? Did he use extra clay or not? Good, he just converted that amount of cone, that amount of clay into the sphere. So he did not change the volume or the quantity. So here we can say that cone is transformed to sphere. Now, so what does it mean? It means the volume of cone is equal to the volume of sphere, isn't it? Because he didn't add or subtract any quantity from this cone. Okay, so the volume of cone is equal to the volume of sphere. Now he has some spherical balls, and now he convert all the balls into a big sphere. Again we know that volume of these each sphere is equals to the volume of big sphere. So what did we conclude from this one? We concluded that volume of each small sphere into number of small spheres, or we can say the total volume of these small sphere is equal to the volume of bigger sphere. So it is equals to volume of the bigger sphere. Now again he changed the volume of cylinder into volume of cone. So here we can say that volume of cylinder is equals to the volume of cone. So today I think now you got some idea that what we will do in the today's chapter. So today we we will learn about the change of the solids, okay, conversion of the solids into different solid. Now we have some number of cylinders, and then he converted it into cone. So here we can say that 4 cylinders are transformed to one cone. So what does it mean? Yes, very good. Volume of the 4 cylinders is equal to the volume of one cone, okay, because we have 4 cylinders and then we have one cone. So volume of these 4 cylinders is equals to the volume of that one cone. So here cylinder is transformed to cone. And volume of the cylinder is equal to the volume of the cone. So here we have, if we have 8 centimeter height and 3 centimeter of radius, and the radius of cone is 4 centimeter. So from here we can find the height of the cone. How is it possible? We will use this statement, volume of the cylinder is equals to the volume of the cone. Okay, I think you already know what is the volume of cylinder. Do you know, students? Okay, tell me, what is the volume of cylinder? Yes, very good. It is pi r square h. And what is the volume of that cone? Do you know? Okay, so it's a very correct answer. The volume of cone is 1/3 of cylinder, so we can write this one as 1/3 pi r square h. Okay, so these are the formula to find the volume of. So here we know, and use this for, and after solving we can find height of the cone. Okay class, now it's question time for you. So again, be ready with your rough device. Here you have to find the volume of the adjoining object. So what is the object? So I think you can find the object, you can find the volume very quickly, and your time starts now. What is the volume of this object? So I think you already know about this object. This object is, it is cuboid. Okay class, so it's a cuboid, and we already know, sorry class, so we know that the volume of cuboid is, yes, tell me. It is good, very good, into B into H. This is L. How much is this? Very good, 4. This is L. What is this? It is again 4, and this is height. This is again 4. So we have length, breadth and height all are same, 4 4 4, or we can say this is a cube. Okay, it's a type of cuboid. So we can multiply 4 into 4 into 4, and your answer is 64. So it is very easy question. So correct answer is C. Okay students, now we will solve some related problems. Now read this one, metallic sphere of radii 6 centimeter, 8 centimeter, 10 centimeter. So we have 3 metallic spheres respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. So what you have to find? The radius of the resulting sphere. Again look here. So we are given that there are 3 metallic spheres. Here you can see one sphere, and its radius is 6, another has 8, and next one has 10 centimeter. So we have 3 spheres whose radii are 6, 8 and 10. So we can write this one as R1, R2 and R3. Okay, so here you can see that we have 3 solid spheres. Again, they all are melted and form a bigger sphere. After melting, they are combined into one big sphere and whose radius is unknown to us. Okay, we have to find the radius of this sphere. Okay class, so we have to find the radius of this sphere. So how will we solve this one? Do you have any idea? Yes, we will use the same statement which we have studied just in our previous slide. We can use the volume of all 3 spheres into one sphere. So we can say that volume of all 3 spheres equals to the volume of bigger sphere. So we can find volume for this one, then for this one. Let R1 be the radius of first sphere, it is 6 centimeter. Then we have R2, it is 8 centimeter, and then we have R3 which is 10 centimeter. Okay, so we have 3 spheres whose R1, R2 and R3 are given. Let R be the radius of the resulting sphere. So capital R is the resulting of bigger sphere. So here what we know about this one? We know that the volume of this big sphere, it is equals to sum of the volume of 3 spheres, is equals to volume of first sphere plus volume of second and volume of third. Okay, now we can put the formula for each sphere. Okay, so if we have to find the volume of bigger sphere, do you know what is the formula to find the volume of a sphere? Yes, you already remembered all the formulas. Yes, very good. It is 4 upon 3 pi r. Now we have to pick which r we are using. If we are finding the volume for bigger sphere, so we will use capital R. Okay, if we are using for this one, so we will use small r. So the volume is, yes, it is 4 upon 3 pi capital R cube. Then we have first sphere 4 upon 3 pi R1 cube, then we have R2 cube, then we have R3 cube. Now we have to solve this one. Okay, first you have to check, is there any common between all 3 terms? So we can take out 4 upon 3 pi, and then we are remaining with R1 cube plus R2 cube plus R3 cube. Okay, we take out 4 upon 3 pi from each term. Now we can cancel out this one. So after cancellation we get this R cube equals to R1 cube plus R2 cube plus R3 cube. Now we can put the values for each one, and then after solving we will get the answer. So it's so easy. So 6 cube is 216, 8 cube is 512 and 10 cube is 1000. And then we have to find the cube root of 1728. Okay, and do you know what is the answer? You can find by factorizing. It is the cube root of 12. So radius of resulting cell is 12 centimeter. Okay, now look at the another question. A cylindrical bucket 32 centimeter high. So what we are given, H with radius of base 18, this is R, is filled with sand. This bucket is emptied on the ground and the conical heap of sand is formed. Okay, so first let's take the imagination what this question is saying to us. So first we have cylindrical bucket. Here you can see it's a in which shape? Very good, it is cylindrical shape. Here we have H 32 and R is 18 centimeter. So it is filled and then it forms a cone. So same quantity of sand which are in cylindrical bucket is then emptied on the ground and then it form a conical heap of sand. Okay, now we are given the height of this cone. The height of the cone is 24 centimeter and we have to find same radius. Again we will use, okay, now we will use the same theory that the volume of cylinder is equals to the volume of cone. So here we have to find the radius, and again slant height of the heap. Let h1 be the height of cylinder and h2 be the height of cone, and again h1 32 and h2 is 24. Again the radius, the radii are different, so let r1 be the radius of cylinder and r2 be the radius of cone. So we have r1 18 and r2 is unknown. So what is it? Yes, very good. The volume of cylinder is equals to the volume of cone. We will equate both the volume of solids, both solids. Now it is equal to the volume of cylinder, and the volume of cylinder is equals to the volume of conical heap. So again, what is the volume of cylinder? So we know that the volume of cylinder is, yes student, very good, it is pi r square h. But if you can check for the cylinder, so we have r1 and h1, so we can write this one as pi r1 square and h1 square. Okay, you don't need to write the same r and h if they are not same. Okay, if they are different, so you have to use different symbol for the radius and the height. Okay, so we will use this one for cylinder. So it is equals to pi r1 square and h1. Now again for volume of cone, we have 1 upon 3 pi r2 square and h2. Okay, I think now you know why do we use r1 and h1, r2 and h2, because these are different. And after solving, you can put all the values here. Then r2 is 3 8 ja 24, and here you have to find the root of, it is 18 into 2, which is 36 centimeter. So here we have radius of sand heap, which is r, 36 centimeter. Again we have to find the slant height, so we can use the formula for slant height. It is h2 square, L equals to r square plus h square, so we can use this one. It is 24 square plus 36 square. Okay, so then we can find the slant height. Okay, now it's question time. The volume of the hemisphere of radius 3, here radius is given to you and you have to find the volume. and your time starts now. Solve this question. Okay, class. So which formula we will use? We will use, very good, 2 upon 3 pi r cube. Now we have 2 upon 3 pi. What is the r? 3 into 3 into 3. Cancel out 1 3, and then you have 3 3s are 9, 9 2s are 18. So the correct answer is yes, C. Okay, now next question. 20-meter deep well with diameter 7. So this is our shape of the well, and you know which shape is this? Can you guess? Yes, very good. This is in cylindrical form, so we have to deal with the volume of cylinder. Then it is evenly spread out to form a platform 22 meter by 14 meter. So then we have to made this sand with this kind of platform. Okay students, and which platform is this? It has breadth, height, and then we have to find the it has length and breadth, and then we have to find h. So which platform is this? Yes, very good. It is a cuboid. So this kind of shape is this. So we will form a cylindrical well which has depth. It is 20 meter. So you can say that this is the height of the cylinder. Okay, we can take it as a height. And the diameter is 7 meter. So we can find the radius, which is 7 upon 2 meter. So here we have h and r. And on all the soil is then spread out to form a cuboidal shape. It is given L 22, and then we have B, which is 14, and we have to find the H. Again we will use the same method. What is that method? Volume of cylinder is equals to the volume of cuboid. So how will we solve this one? Let r be the radius of the well. So r equals to 7 upon 2. Then height, we can take it as h1 because there are two height, first for the cylinder and another for the cuboid. R equals to 7 upon 2 and h1 equals to 20 meter. And let h be the height of the platform. So it is given L 22, B 14, and we have to find the h. Now volume of the earth dug out. So it is in the form of cylinder, so we can take it as volume of cylinder, and the volume of the cylinder is equals to the volume of the platform, which is cuboid. So volume is L into B into H. So now put all the values and solve this one, and then you will find H1 is 20 meter, then we have L 22, into 14, then into h. Put the value of pi. It is very good, 22 by 7. So then we can find the height. Volume of the sphere of radius 3 centimeter. Here radius is given and you have to find the volume. Your time starts now. Find the volume of this sphere. It is solid sphere. Okay class, your time is over and the correct answer is 36 pi centimeter cube. A farmer connects a pipe of internal diameter. So this is a pipe and you know the shape of pipe is, yes, very good, it is cylindrical, into a cylindrical tank or in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? So to find the time. Here what we are given, now look here, we are given radius of pipe because diameter is 20 centimeter. So from here we can find the radius, which is 10 centimeter. Now what is the height? Height means length of the pipe. So if you can see here, this is our pipe. Here radius is given 20, but what is length? So to find the length we have to take the rate. Rate means it is it is given speed of the water. Okay, so the rate is 3 km per hour. What it means? It means that in 1 hour it covers a distance of 3 km. So if we take the water flowing in the 1 hour, so the length of the water will be 3 km. And what is the time in 1 hour? So we can take this 3 km as the height or length of the cylinder. Now the amount of the water that flows through the pipe in 1 hour, it is equals to the volume of the inner cylindrical pipe per hour, because we are using volume for 1 hour. So we can take this 3 km as h. Now what is the volume of inner cylindrical? We have to find the volume of cylinder. And volume of inner cylindrical pipe in n hours, it is equals to the volume of water in the tank. So here we can use all these values given to us. Let V1 be the volume of inner cylindrical pipe and V2 be the volume of the tank. Now the volume of cylindrical pipe, and it is multiplied by n, which is time, because we are finding the V1 for 1 hour only. So we have to find in how much time. So we will multiply this volume by n. So it is equals to the volume filled in the water tank. It is equals to V2. Now put the values of V1 and V2 here. To solve this one, first we have to change the units of all these, because some are given centimeter, some in kilometer, some in meter. Okay, so we have to change all these units into one single unit. So here we will use this formula. So we can change all these units into centimeter, because centimeter is smaller unit. So we have to multiply. So 1 meter is 100 centimeter and 1 centimeter is 1 upon 100 meter. Again change centimeter into meter. So it is equals to 0.1 meter. Then we will change kilometer into meter again. So it is 3000 meter. And then we have R1 5 meter. So after solving this one, the n is 1 whole 2 upon 3 hours, because we have taken the time in hour. So this is our answer. Here we can change this hour into minute also. So we can write this one as 1 hour 2 upon 3 into 60 minutes. So it is answer 100 minutes. How many silver coins? 1.75 centimeter in diameter. So again we have to find the number of coins. So can you tell me which shape is this? Isn't it a tricky shape? So can you guess? Yes, very good students. This is cylinder. Which kind of cylinder? A cylinder whose height is very small. Okay, if you have a cylinder and you press this cylinder, so you will get this kind of shape. Here radius and height is given to us. After melting, it forms a block of cuboid whose dimension is given to us. Okay, so here first we have to change all the units into same unit. So these all are in centimeter, so we can change this one again in centimeter. So L is given, B is given, H is also given. Let H1 be the thickness of the silver coin, which is 2 millimeter, and R is 1.75 upon 2 centimeter. Now volume of cuboid equals to volume of each silver cone into number of coins, because we have to find the number of coins. So volume of cylinder into number of coins. Okay, now put all the values. L 5.5, B 10, H 3.5, value of pi 22 upon 7, then volume of R square, and we can take 2 mm into centimeter. So to change into centimeter, we will divide by 10. Okay, then after solving we will get the answer, and the n is 400 coins. So number of coins are, what is the number of coins? It is 400. If the radius of and the height are 3 and 7, so volume of the cone, what will be the volume of cone? Okay class, so the answer is C, it is 21 pi. A container shaped like a right circular cylinder having diameter 12 centimeter. So first we have to imagine which kind of shape is this. So it is right circular cylinder. So we can take this cylinder, its radius and height is given to us. So radius is half of 12, which is 6 centimeter. H is 15. So it is full of ice cream. Okay, so we have to find the volume of cylinder, and then it filled into cone and height of 12 centimeter. So this is not a simple cone. Okay, if you look carefully, so you will find that this part is cone and the upper part is hemisphere. So to find the volume of this combination, we have to find volume of cone plus volume of hemisphere. Yes, so you can take this one, and here we have to find the number of such cones. Let R1 be the radius of cylinder and H1 be the height of the cylinder. H2 be the height of the cone, which is 12 centimeter. Now the amount of ice cream contained in the cylinder is equals to the volume of the cylinder. So here we have to find the volume of cylinder, and which is equals to volume of each cone, means volume of one cone plus volume of each hemisphere, because this cone is composed of two parts. First is cone and another is hemisphere. So we can put the values. Volume of hemisphere is 2 upon 3 pi r2 cube, and after solving you will get the answer. From here we can find the number of cones. It is equals to 10. So number of cones are 10. Okay class, the volume of the adjoining cuboid is, and your time starts now. What is the volume of this cuboid? Okay, and your time is over. The correct answer is D, which is 120 cubic centimeter. Okay class, now it's a feedback question, and your time starts now. So how do you find today's class? Okay students, time is over. So what we learned today? So we learned the how to find the volume if one solid is converted into another solid. So to find this one, we have to equate the volume of each solid to volume of another solid. Okay, then we can find the unknown value, some like the radius, height, and the number of the objects. Okay, so now it's time to end the class, and what you have to do, you have to find more problems and try to solve all of them. Okay class, so it's time to end the class, and we will meet in next class. Till then, goodbye and thank you.